Welcome to the AI Research Roundup. I am Alex. Today, we're diving into this article by Google Research, Differential Privacy on Trust Graphs, from May 13, 2025. It addresses how differential privacy, a method protecting individual data in analyses, typically relies on a central model, with one trusted data holder, or a local model, where no one is fully trusted. This post introduces Trust Graph Differential Privacy, or TGDP, using a trust graph, a network of user trust, for more flexible privacy. Researchers explore algorithms and limits within this new trust graph differential privacy framework. Okay, so this figure really helps visualize how trust graph differential privacy fits in with what we already know. On the left, you see a star graph. This represents the traditional central model of differential privacy, where all users connect to and trust a single central curator, like a server, with their raw data. Then, on the right, there's a fully unconnected graph. This illustrates the local model of differential privacy, where users don't trust anyone else, so privacy is handled on each user's device. Trust graph differential privacy can model both of these scenarios, and everything in between. Now, this next figure provides a more concrete example of a trust graph in action, specifically for location sharing. We see Alice shares her location with Bob. Bob, in turn, shares his with Carol and Dave. And then Carol and Dave both share their location data with Eve. The key idea here, under trust graph differential privacy, is that even if Carol, Dave, and Eve combine all the information they have, they still should NT be able to figure out Alice's specific location data, because Alice only directly trusts Bob. This really illustrates the nuanced privacy control. Alright, so building on that idea of trust graphs, this diagram introduces a concept called a dominating set. We see the same network of Alice, Bob, Carol, Dave, and Eve. But here, Alice and Eve are highlighted in blue. They form what's called a dominating set, often denoted as T. A dominating set, in graph theory, is a subset of vertices, or users in this case, such that every user not in the set is connected to, or trusts, at least one user in the set. This idea is then used to build an algorithm for data aggregation while maintaining trust graph differential privacy. So, this work on trust graph differential privacy introduces a really flexible way to think about data privacy, moving beyond the all-or-nothing approaches of central or local models. The researchers have proposed algorithms for tasks like data aggregation, using graph theory concepts like dominating sets, and they've also established some theoretical limits or lower bounds on how accurate these can be, which relate to something called the packing number of the graph. It's an interesting step towards more nuanced privacy in real-world systems. That's all for this AI Research Roundup. Thanks for tuning in.